All right, in this video, we are going to solve these trigonometric equations over here. Some of them are quadratic and some of them, or most of them are going to use some kind of trig identity. And we're going to solve them between 0 and 2 pi. So let's start with the first question over here. The first thing we want to do in this one is we want to basically expand out this bracket. So I'm going to write out this bracket twice. And then I'm going to FOIL out the two brackets. So sine times sine is sine square x. Sine times cos is sine cos, and cos times sine is also sine cos. So if I add those two together, I'll get plus 2 sine x cos x. And then cos x times cos x is cos square x. And this still equals to 1. The next thing I'm going to do is I'm going to use my trig identity where sine square x plus cos square x equals to 1. So I'm going to replace the sine square plus cos square with a 1. Then I'm going to take this 1 and I'm going to subtract it on this side. So 1 minus 1 is just 0. Basically, these cancel out. I'm left with 2 sine x cos x equals to 0. So this is in fully factored form. I can split this into two equations, sine x equals to 0 or cos x equals to 0. To solve these, you want to use your graphs. So over here, I'm drawing it between 0 and 2 pi for sine x. So that's 2 pi and that's pi over there. So sine x equals to 0 at 3 different points, 0, pi, and 2 pi. So my solutions for this first one are 0, pi, and 2 pi. And for this equation here, I will draw a cosine graph between 0 and 2 pi. So there's pi over there, and there's 2 pi, and this is pi over 2, and this is 3 pi over 2. So cos is 0 at pi over 2 and 3 pi over 2. So my two solutions are x equals to pi over 2 and 3 pi over 2. So in this first question, we have 5 solutions in total. Let's go to the second question over here. And again, there are multiple ways to do all of these questions, I believe. I'm just picking the easiest way for me. But like I said, there are always multiple ways to do this. So in this question, I have sine 2x and then I have sine 4x. So what I want to do over here is I want to make the internal brackets the same because that's going to make it easier to factor. So I'm going to convert the sine 4x using the formula sine 2x equals 2 sine x cos x, basically my double angle formula for sine. I'm going to use that to convert this into 2 sine 2x cos 2x. So I've just used my double angle formula over here and split this up into this. Once I do that, I can common factor out sine 2x. So if I common factor out sine 2x, I'm left with 1 minus 2 cos 2x equals 0. And now this is fully factored, so I can split this into two different equations. My first equation will be sine 2x equals to 0. My second equation is 1 minus 2 cos 2x equals to 0. So now I have to solve each of these separately. Let's start with this one here. Again, I'm going to use a sine graph for this, but the K value is 2, which is a horizontal compression by a factor of 2, which means that I'm going to have 2 cycles between 0 and 2 pi. Makes this pi over here, and this as pi over 2, and this as 3 pi over 2. So over here, from the first equation over here, we already have 5 solutions. X equals 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now let's go to this second equation over here. I'm going to move this to the other side so I make it positive. Then I want to divide both sides by 2. So if I divide both sides by 2, I will get 1 over 2 equals to cos 2x. And now I want to use my cos rule to solve this. Cos is positive in the first and fourth quadrant. I'll do the cos inverse of 1 over 2 to find my acute angles. You could also use special triangles here, I believe, but I'm going to stick with my calculator for this one. And you'll get pi over 3. If you're not allowed a calculator, you can still use your special triangles over here. So I know that my first solution here is just pi over 3. So cos 2x, oh, sorry, not cos 2x, just 2x. So we got rid of the cos there. 2x equals pi over 3. And my second solution here is 2 pi minus pi over 3. So 2x equals 5 pi over 3. Then I need to isolate my x in these examples. So to isolate my x, I'm going to divide by 2. So x equals pi over 6, and x equals to 5 pi over 6. Now, since we have a k value of 2 and our period is pi, we're going to actually have 4 solutions here in total between 0 and 2 pi. Because if you just have a regular x there, no 2, you have 2 solutions. If you have a 2 here, you have 4 solutions. If you have a 3 here, you have 6 solutions. So how do I find the last 2 solutions in this question? I know that my k value is 2, and I know that my period is 2 pi divided by k, which is 2 pi divided by 2, which is pi. So all I'm going to do is I'm going to take my period and I'm going to add it to these 2 solutions, which means that my next solution here is pi plus pi over 6, which is 7 pi over 6. And my next solution here is 5 pi over 6 plus pi, which is 11 pi over 6. So in this question, we have a total of 5 plus 4, 9 solutions total for this question over here. If you made it to the end of this video and you found this content helpful, please hit that like and subscribe button as it really helps this channel. Thank you for watching and have a wonderful day.